This talk is called Dangerous Minds, and of course it refers to the 1995 movie starring Michelle Pfeiffer. And I've always wondered why that movie was called Dangerous Minds. I couldn't find an official reason, but of course, if I ask ChatGPT, it'll speculate and come up with something. But of course, we're not here to reminisce about movies from the 90s, no matter how amazing the soundtrack is. We're here to talk about software engineering. So in the context of software engineering, what's a dangerous mind? And you might think that the imminent danger is something like ChatGPT or language models, and they're going to replace all of us, or they're going to replace juniors. That's where the real danger is. So I actually think that time is quite far away. It's still very easy to get nonsense from ChatGPT. So what then are we referring to with dangerous mind? Well, for the purposes of this talk, a dangerous mind has no sense of the profundity of software engineering as a discipline. And a dangerous mind has this really superficial knowledge, but also a lot of overconfidence. And a dangerous mind also wastes energy in arguing about things that don't really matter at the end of the day. So you might see where I'm going here. Basically, when you're talking about learning any complex skill, like learning to code or learning to spell, you start by learning rules, really simplification. So in English, for example, if you were learning English spelling, you'd learn I before E except after C, which is of course not universally applicable, but you have to start somewhere. And after a while, you start to get more familiarity with the rules. But eventually you proceed to a state where you have an intuition about what works and how to spell, and you have a big picture. And that's been my experience working with really talented engineers. So when I've had the privilege to work with them, they have this amazing instinct and intuition for what will work in a particular context. And they also have this expansive expansive vista over the entire field. So that's where we'd like to go. But as pointed out in this famous blog post, How Developers Stop Learning, The Rise of Expert Beginner, many people just start learning the rules, and once they're familiar with these, they get stuck in this local maxima, and they start to think, okay, well, I know all the rules, I'm an expert now. And even if they have a glimpse of what's beyond, they think, okay, well, it doesn't really, that's not really relevant, or it's not that important, because if it was that important, I'd already know it. And this is a real tragedy. Like, if you're stuck in that local maxima, then it sucks for you, it sucks for your teammates. And we talk so much about this productivity boost from AI, but wouldn't it be amazing if we had this productivity boost for people's careers, so that they proceed very quickly from novice to expert? And the thesis I wanted to explore in this talk is that a lot of the advice that we give to people who are learning to code and to newer developers is actually inculcating this expert beginner mindset, this dangerous mind. So we're going to start by looking at some advice. The first piece of advice is about naming, and we're going to see how it's wrong and how it misses the bigger picture, because remember, the bigger picture is what the expert beginner lacks. So here's an example from a text, a book aimed at beginner developers. So it's talking about naming classes, and it says to avoid words like manager, processor, data, or info. So remember, it said to avoid data. That's actually quite difficult. So if you look at the Now and Android project, it has this class called user data, which essentially represents a bundle of information associated with the user. And it seemed that user data is actually an adequate name for something like that. And a further example is from the DuckDuckGo Android project. So DuckDuckGo is developed in the open, so it's a really good example of if you want to see how a big Android project is developed, you can look at that. And they have this AmpLink info, and often you end up with this situation where you have the thing itself and something you want to associate with it. And if you don't use data or info, it's actually really, really difficult to come up with a name. And you might think, okay, why not use a tuple like pair string string or triple string 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 and so on? But tuples have their downsides as well. And remember, we were told to avoid processor. Processor, sometimes you actually do have a processor in your app, like an annotation processor or an image processor, or if you're separating calculations from actions and you're building some kind of pipeline. And you might say, okay, well, it just says avoid processor. It's not saying that you can never use processor. My experience is that people take that advice very, very seriously, almost as if it was inscribed on stone tablets. So, and furthermore, if it's beginner advice, if it's advice that's aimed to teach, then it should be really clear, and we shouldn't have to perform hermeneutics on it. We shouldn't have to say, hey, when author X says X, he means, when author X says this, he actually means Y, he actually means something else. So that advice falls down in some way there. So the last piece of advice is to avoid manager. And this is a little dangerous, I think, when there's a lot of public APIs around that already use manager, and you say don't use manager, it kind of directs attention to public APIs at a point where you should be concentrating on your own APIs and improving them. And this is, of course, Activity Manager from the Android open source project. But in a way, that kind of advice confuses a local problem with a global problem. So you can imagine some project where there's a category of abstraction where it's actually perfectly valid to call it manager. So if, for example, the repositories now in Android, if we just happen to name them manager, then that code wouldn't suddenly become unclean or intolerable. And in modern software engineering, if we wanted to solve that problem, we'd solve it for our project, and we solve it using code scanners or using static analysis. So if we wanted to put manager into band world, then all we needed to do if we were using detect would be to add 3 lines of YAML config. Or if we were using lint rules, usually the lint rules that deal with names are some of the easiest ones to write. So it's not this issue. It's not this big issue that it often gets interpreted as. And going further, there's a bigger picture that advice like that misses. So let's approach this problem here. What do you call a file where you're putting extension functions for a class called offsets or offset? Do you put it in offsets.kt? Do you put them in offset extensions.kt, offset lowercase, or offset.utils, or something like that? Now you might think, okay, well, in Java we have java.util.concurrent.executors, and that's where the factory functions for executor go. So that's a really nice convention, and we're avoiding this verbosity from coming up with a name like executor extensions or executor factory or whatever. And that approach might work well for user, where you put the extension functions in users.kt. But it's a little harder for things like gold, where you end up with golds.kt, which gold is an uncountable noun in English. And you can end up with all sorts of cases that don't really work. Like, what if you have a faux pas? That's actually very hard to pluralize. And you end up with this kind of problem with names all the time. So in Column Poet, things that can have an annotation are called annotatable. Things that can have documentation are called documentable. what do we call something that can have a type spec? So even ChatGPT can't really help here and come up with a name that is perfect. So you can level all kinds of criticisms towards names. So there's this famous blog from 2006 called "Execution in the Kingdom of Nouns," and it's parroting or it's criticizing Java. It's saying that in the real world you would say, get the garbage bag from under the sink, carry it out to the garage, and dump it in the garbage can. But in Java, you'd have to do something like this. You'd say retrieval strategy factory.create, and you'd essentially relegate all those actions to just these nouns, which are these nouns or these classes, which are responsible for just one or two things. So you could even argue that Jetpack Compose succumbs to that criticism. So we have a focus requester, and we use that to request focus, similar to how we how in the article you use the garbage bag collector to pick up the garbage. But one response to that is we're not trying to write a teenage vampire novel. Names aren't the only concern here. So in the 30,000 line view.java, request focus is a member. So yeah, you can say view request focus, and that sounds a lot more like Twilight, where it's mainly Robert Pattinson's character does this and Kristen Stewart's character does this. But that's not the only concern. We're also concerned about API design, where we want components to be relatively simple and easy to understand. So I reviewed a pull request recently where the developer had learned this rule using get in function names is ambiguous. So they twisted themselves into all kinds of knots trying to find different alternatives to capture what they were trying to do inside that function. So maybe it's easier to just use get for all of that. So that's what the KSP API does, and it's really, really easy for API discovery. If you're in a particular class or using a particular type, you don't have to think, okay, now do I have to type in calculate to get what I want, or do I have to type in retrieve to get what I want? So the point is, we have these little tools that we use to help at the end of the day put something on the screen, and their essence is almost uncapturable by language. It's almost like mathematics, where you have some very abstract concept and you associate it with something concrete like the Greek letter pi. So I'm not saying that names don't matter. I think names are very, very important, and you should spend a long time sweating to get the right name. What I'm saying is that names aren't a solution. So many problems in software engineering, you're choosing between a number of alternatives where all the alternatives have some disadvantage, and you're just choosing the one with the most disadvantages, or with the least disadvantages, sorry. And if we don't remember that when we give out advice, it becomes a little bit like Mr. Bucket. So if you don't know Mr. Bucket as a children's game where there's a motorized plastic bucket and it spits out ping pong balls, and the children run around with plastic spoons and try and retrieve the ping pong balls and put them inside Mr. Bucket. So just like Ilian Germanov from Reddit explains here, to put it with the analogy of Mr. Bucket, the influencers or the consultant types, they spit out the ping pong balls of best practice and anti-pattern advice. And the people who are just trying to level up, who are trying to get ahead and become more productive, they run around with the plastic spoons and try and internalize all of these best practices. And it's thinking that's how you're going to get ahead, that's how you're going to become an expert. And it's not a good situation. It actually cheapens the whole discipline of software engineering to present advice in that way. So if we were going to take this advice and rewrite it in a way that doesn't lead to this dangerous mind, what will we do? Well, I had a go, and I'd be interested to hear and see what you think as well. But the way I would write this advice is getting a good instinct for names is hard. So the reason I've said that first is because we want to give a sense of the final destination where you have an instinct or intuition for what's right. And then I've put you will need to learn to walk the tightrope between obscurity and verbosity. So again, we're trying to give a sense of trade-offs. So then I put follow the idiomatic names in your language and open source community. So the reason for mentioning community here is community is like garlic for the vampire of the expert beginner. So if you remember, the expert beginner gets stuck, and part of the reason is because they don't interact with their peers. They're just almost in this solipsis of experthood. So when you start to interact with your peers and see what they're doing, then you start to worry less about the magical project in the sky that never uses data and a class name, or never uses info. And you start to see that actually we have to make a trade-off at some stage for something that's imperfect. Then I've put for teams using, for team projects, enforced naming conventions using static analysis to avoid bike shedding, because we don't want our advice to end up with a situation where we get people who are very, very attached to one particular piece of advice and go around from project to project and imposing their advice about something cosmetic on that project. So finally, I put at the end of the day, decisions on names are compromises too. So learn to deal with names that aren't perfect. So that was some advice about names that I thought could go a little bit awry. Let's look at some advice about testing that could also lead to this dangerous mind. So some of you might be familiar with this advice about testing, that testing is like testing in general and test-driven development are like double entry bookkeeping. So just in case you're not aware, double entry bookkeeping is where every single transaction has an entry in multiple ledgers, or every transaction has a entry in equal and opposite reaction in another ledger. So kind of like Newton's third law. So let's say you take out a loan for $10,000, then you end up with 10,000 in debit to represent the asset that you now have, the $10,000 cash. And then in credit, to represent your liability, you'd put $10,000 there as well. So applying that analogy to testing is actually a little bit harmful. Like let's consider this production code we have here, the payment processor. So to my mind, the worst kinds of tests, like this naive test here, has this double entry property where every implementation detail of the production code has an equal and opposite entry in the test code itself. So this is talking about the overuse of mocks, of course. The problem with this double entry is that it's a tautology. So it's like a snake trying to sustain itself by eating its own tail. So the production code is correct because the test verifies it's correct. The test is correct because, well, it copy pastes the implementation details from the production code. And I can even remember thinking of testing this way at some point as a beginner. So I'd write this really sloppy production code with like a really coarse error, like a spelling mistake there in the spelling of birthday. And I wouldn't even check it through or look twice, and I'd just immediately jump to writing a test. And the test would find a coarse error, and I think to myself, oh wow, testing is so, my unit test is so profound. But really, I just written the value there was from double checking my work. It wasn't from writing the test. That test wasn't of benefit to the project as a whole, and to my fellow developers, and to and to maintaining that particular class. So you might say, okay, well, even if we rewrite that using fakes, then it's still tautological because the fake mirrors the production code. So I think it's a little bit different for fakes. With intention, when you're writing a fake, the intention is to produce a minimal, simplified version of a dependency. It's not to monkey patch the dependencies of the system under test inline in the test body itself. Furthermore, when you're dealing with tests, usually when you're dealing with fakes, usually you think about faking just at the lowest level possible. You're not thinking about, you're not insisting on mocking every single dependency of the system under test. So the classic example is you replace a database with a disk database with an in-memory database. So that's my take, but there's an even better take, which is the take from software engineering and Google, lessons learned from programming over time. So this is a really amazing book. You can get hard copy or it's available online. And it's about Google's journey to scale their projects and scale their code base. And there's chapters that deal with scaling testing. And you might think, okay, well, Google scale doesn't apply to everyone. Unit tests are something that scale quite quickly. Like even in a small project, you can end up with hundreds of unit tests, and that can slow you down if you get the wrong patterns. So the chapter about test doubles, when we're talking about mocks, fakes, stubs, and spies, has a really profound presentation. It talks about test doubles in terms of applicability. So that means whether using that test double is a good idea for that particular use case. And then within that, it has a discussion of whether using that test double makes your test code brittle. So in other words, if you're writing test code that has to change when the implementation details of your production code change, whether that test double is making you write your tests in a way that obscures the intention of the test. And also discusses the test doubles in terms of fidelity. So how true they are to the production code. And most Android projects I've worked on don't even get to this point. They don't even get to this discussion. It's different to look at that advice and understand it and to say, okay, well, yes, that's an ideal, but we can't meet that right now because maybe we have a lot of investment in mocks already, or maybe the level of the team isn't quite there yet. But a lot of projects don't even get to that point, and I think it's really sad. When you look at the reason for that, it's really hard to think that doesn't come from the way that advice on testing is presented. A lot of advice about unit testing focuses on the amount of tests and when you write the test. So there's a lot of advice that insists you write the failing test before you write the production code. In case you think I'm joking or I'm being mean to one particular person, you might remember the layoffs at Twitter that happened a while ago. And so no matter whatever you think of the politics of Twitter, there were some really amazing engineers who were laid off. And at that time, a video came out, which I thought was a little bit opportunistic. And it speculated that the Twitter devs were laid off because they didn't write enough unit tests. So it's almost like that meme, like the number of unit tests is too darn low. And I thought it was quite sad. And it was really disappointing to see that kind of really superficial level of discussion about testing, where there's this really amazing depth that you can see in books like Software Engineering at Google, Lessons Learned from Programming Over Time. So to conclude, there's all these kinds of advice that you might come across, and I think it's really easy if you're a beginner to confuse that advice, to confuse a forest with the trees, and to just try and become a repository for all these sound bites, for all these tips. And it's really easy when you're giving out advice as well to present it in a way that doesn't give us a sense of the big picture. So we've talked about one book that I really like, but another book I've mentioned in the past is A Philosophy of Software Design by John Ousterhout, who's an amazing professor at Stanford. And these books, they'll have to present advice. Like you can't just raise your hands and say it depends and there's nothing you can do. But they'll present advice at a different level, in a way that doesn't lead to this dangerous mind, to this expert beginner mindset. So, for example, one of the pieces of advice from A Philosophy of Software Design is to design it twice. So it's saying that software design is really, really hard, and your first design won't be the best, so you have to present multiple options. So that's all I wanted to talk about today, and I'd be happy to answer any questions on this topic.
Thank you for that talk. Yeah, that was great. One question that might be applicable is, how could someone who's maybe on the younger end of things, who is just getting started and maybe they don't have a team around them, how could they maybe reach out to the community to learn, hone this craft, to learn what they are approaching dangerously, as opposed to just consuming those sound bites? How can they get that good community direction like you were talking about?
That's a really good question. So I think the one thing you could do, for example, is to just start following an open source project and just watching it and looking at the pull requests, looking at the issues, and follow it for some length of time. Then you'll start to see some of the trade-offs we talk about. Like, often when there's code review and there's really senior developers involved, really expert engineers, there'll be some discussion of that, and that really gives you that's going to really give you an advantage, I think, if you're a beginner.
Cool, great. And we have a question from Robert. I'll show that. So what was the first book you recommended again?
Right. So there was Software Engineering at Google, Lessons Learned from Programming Over Time. And that's available free online. And the second book, which I've talked about before, is called A Philosophy of Software Design by John Ousterhout.
Great. Thank you. I don't see any other questions in the chat. We can give it a few seconds to see if any other ones pop in. But, yeah, maybe another, or yeah, maybe one last thought is for those who are more senior and who have teams. Are there any steps that you take when you're talking with your team to try and discern whether or not you're like just handing down a list, or whether you're helping to create a mind that is not going to be dangerous?
Yeah. So one of the things that I've seen that really helps is when teams have some kind of design doc process, and where like a RFC or like a ADR, architecture decision record. So when you're going to do something profound, or something that touches multiple teams, or something that something where there's a lot of unknowns, you start to plan, and you give a number of alternatives, like, use this endpoint and do this, or build a new endpoint and do something else, and then you discuss the advantages and disadvantages of each approach. And I think that really helps inculcate this mindset that there's no solutions, there's only trade-offs, and the kind of engineering mindset that avoids bike shedding. I think that approach can really help.
Great, thank you. We have another question from Robert. Any thoughts on bad tests, good tests by, I cannot pronounce that name, I'm sorry.
Okay, I'm not actually familiar with that article. Thanks for pointing it out. I'll have a look at it.
Cool. Well, with that, thank you so much for being here, for doing the talk, and I'll hand it over to Sarp to take it from here.
Cool. Thanks, Jesse.